Hey guys, hey, welcome to week 4. Oh my God, I can't believe it's already week 4 of our emergency learning plan. That means after this week, we have one. Yes, that is right. One more activity to do, and that is amazing. Well, let's get through this week first before we start the celebration. So this week, we're talking about area, perimeter, circumference, and then what we call composite figures. So last week, we kind of started to look at this formula sheet. We're going to continue to dive into the formula sheet. Last week we were on Pythagorean's theorem, but this week we're really going to focus on the two-dimensional shapes towards the top. Now remember, you do not have to memorize these formulas. So if you're like, oh my gosh, I don't, there's L's and W's and H's and B1 and B2 and what do I do with pi and all this other stuff? Do not worry. You don't have to memorize the formula. It'll always be available to you kind of with the formula sheet. Until geometry, there'll be some that you have to memorize, but until then, that'll be your 8th grade year. Until then, there's really not much that you have to memorize because, again, you get a copy of this formula sheet. So I'm going to show you some tricks with the Desmos calculator on how to go through and find like area, perimeter, and circumference, and then how to break down what we call composite figures. So let's begin to explore. So right here we have this little trapezoid. Remember, trapezoid is a type of quadrilateral where the bases, this top and bottom horizontal line, are parallel to each other. So right here, up here on our formula sheet, we have the formula for area of a trapezoid, and then the diagram. B1 at the top, B2 at the bottom, H is the kind of perpendicular line that connects them, right? This right here. Perpendicular means it forms this 90-degree angle. So first step of formulas, let's write the formula. Area equals 1/2 times the height times B1 plus B2. And it doesn't matter if you make this one B1 and this one B2 or vice versa. It doesn't much matter. So let's bring in that Desmos calculator, right? The handy dandy Desmos calculator. The trick last week that I showed you with Pythagorean's theorem is that you can really just type in the formula. Area equals 1/2 times the height, then parentheses. Now here's where it gets tricky. I can't type in B1 and B2. So I'm going to make this one B and I'm going to make this one C, right? It doesn't really matter, but I'm going to make them two different variables. So over here on my calculator, I'm going to do B for B1 plus C for B2. So if I were to work this out longhand, I rewrite the formula and I plug in what I know. 1/2, the height is 5, parentheses, B1 was 4, plus B2 was 9. And then I can use orders of operations to kind of work this out fully and solve. Or I can go over to my Desmos calculator and say, okay, well, the height is 5, B1 is 4, and B2, which I labeled C for the Desmos calculator purposes, equals 9. And just look right there. Boom. 32.5. You see right there? Woo! How amazing is that? So I can say that the area of this trapezoid is 32 and 5/10 centimeters squared. We have to really know how to label those units. So with perimeter and circumference, we just use the units. So it would have been just centimeters. For area, we do centimeters squared. And then for volume, which we'll talk about next week, we do centimeters cubed or whatever the unit of measurement would be. So 32.5 or 32.5 centimeters squared is the area of that trapezoid. Boom. Use the Desmos. Type in the formula, type in what you know, solve for what you don't. Very simple process. Let's go to the next example. So let's talk about a circle. The parts of a circle should really be a throwback to 5th grade. Remember, circumference is the distance around the circle, so it's just a fancy word for perimeter. And then area is the space inside the circle, right? So those are things that we have to know. Diameter is the line that connects two sides while passing through the center. So that's the diameter. And then radius is half the length of the circle. But again, if you don't know that, boom, there's a diagram right here of a circle on your formula sheet. So you don't even have to memorize that part. When I'm looking at a circle, and I want to define the circumference of a circle. If you notice up there at the top, and I won't scroll back up because I don't want to make you seasick, there's two formulas for circumference of the circle. One is pi times diameter, and one is 2 times pi times the radius. Well, if I look at this circle, I know the diameter. So when I choose my formula for circumference, I would choose the one that had the D for diameter, right? Also on your formula sheet, we talk about pi and how pi is about 3.14, right? You remember all the way back to Unit 1, pi is an irrational number that lasts forever and ever and ever. But for our purposes, we round it and say pi is 3.14. So you won't use the pi button on the calculator, which is kind of right here. You will just type in 3.14. So say I want to find circumference. Circumference equals 3.14 times the diameter. And then I tell my calculator diameter equals 4. And then boom, right here, the circumference is 12.56 meters, right? Remember, with circumference and perimeter, we just use the units, so it is just meters. If I wanted to find the area of that circle, the formula for area is pi times radius squared. So I come back over to the Desmos and I clear it out. And now I type in the formula for area. Area equals 3.14 times the radius squared. Now remember, in this circle, I only know the diameter. So if I wanted to use the radius, I cut it in half. This one's very simple. I don't need the calculator. The diameter is 4, radius is 2. So I have my formula over here. I type in what I know. Radius equals 2. And look at there. Area is 12.56, but now it's meters squared. This is a special circle. This is the only circle where the area and the circumference end up being the exact same. But that's okay. I like to show you special things. All right, so now with any of the two-dimensional shapes up here, right, whether it's a parallelogram or a trapezoid, circle, rectangle, square, triangle, you use the formula, plug it into the calculator, plug in what you know, solve for what you don't. So what if you have something called a composite figure? So let's get down here to our first composite figure. So here's what I have, what's called a composite figure. A composite figure is a shape or a two-dimensional plane figure that's made up of different shapes combined, right? So here you can see I have a triangle and a rectangle. If I wanted to find the perimeter of the composite figure, then I just add, right? Add. But what if I wanted to find the area of my composite figure? This one's kind of separated for me. This one has that kind of like line right here that separates kind of the triangle part from the rectangle part. Sometimes you have to draw that yourself, but I need to figure out the different pieces of my composite figure so that I can properly solve for the area of that composite figure, right? So I'm going to find the, okay. So let me find the area first of the triangle, and then I'm going to find the area of the rectangle. All right, so right now, this so area of a rectangle is length times width. So I have the length of 16, the width of 7. So I literally just do 16 times 7, right? So over here, I can do area equals length times width. Length equals 16. Width equals 7. So here, the area of the rectangle is 112 centimeters squared. So let's find the area of that triangle. I'm missing all the dimensions of the triangle. So I have to use what I know about the rectangle to solve what I need for the triangle. So I know that the full length of that rectangle is 16 centimeters, right, from here to here. But from here to here is 8. 16 minus 8 means that right here is 8, right? It shows over here that the full length of the figure is 13 centimeters. Well, I know that this side is congruent to this side. So from here to here is 7, which means if I take my 13 minus 7, if I don't feel like doing actual math today, 13 minus 7 means from here to here is 6, right? So sometimes you have to use the shape to figure out what's missing in the other kind of figure. So the area of a triangle is 1/2 base times height. And the base and the height form a perpendicular kind of 90-degree right angle, right? They're perpendicular to each other. So the base is going to be 8. The height is going to be 6. And over here, I just clear this and I type in area equals 1/2 base times height. Base equals 8. Height equals 6. And the area of my triangle is 24 centimeters squared. So now how do I find the area of the whole thing? I take my 24 centimeters squared. Whoops. Here we go. Let's do this. Plus my 112 centimeters squared. And so the whole thing has an area of 136 centimeters squared, right? Boom. Easy peasy. Just kind of like a puzzle you have to put together. All right, the very last one before we will finish up. This one says, what is the area of the shaded region? So this has a circle with the, rectangle. It looks like a square kind of, but it's a rectangle. See, that's a 6x5. A rectangle on the inside. So if I want to find the area of the shaded region, I have to find the area of the circle and then the area of the rectangle and subtract them. So let's look at area of the circle, which is pi times radius squared. So I have the radius is 4 inches. So I come over to my handy dandy calculator. So 3.14 times r squared. And I tell the calculator that the radius is 4, which means the area of that circle is 50.24 inches squared. Well, let's look at just the rectangle. The rectangle is a 6x5. I don't even need the calculator for this one. A 6x5, or 6 times 5, is 30 inches squared. So if I want to know these kind of little, bluish purple, who knows, bluish purple pieces, I just take in my calculator the area of the circle minus the area of the rectangle, that white part, and the shaded region is 20.24 inches squared. So sometimes you'll add the areas and sometimes you'll subtract depending on the figure. If you're finding just the shaded part, you're going to subtract the kind of like white part. If you're finding the whole thing, then you'll add them together. So really have to read those questions. So what do I do now? Well, now you go and you finish that lesson. Make sure on slide 1, you finish the next video and the notes, and then take the quizzes and type in your quiz's score. Complete the interactive slide, right? The one where you actually have to do stuff. Circle one thing on your choice board. That's slide 3 or 4, depending. Circle one thing on your choice board and then complete your choice. Don't just circle it and then not do it. And don't just post a link to the blank one. You actually have to do it. So when you're done with your choice, remember your choice can be the quiz, like the little checkup in Schoology, or one of those other choices on the choice board. Once you've finished, post a shareable link to your choice, or if you choose the checkup or the quiz, type in that score, and for the love of all things good and glorious, turn in your assignment. All right, friends, if you need anything, just message me. Love you a long time. Bye-bye.